Hello, my name is Jim Bentley, and I'm an educator in Northern California. I'm also a National Geographic Fellow and Explorer and a PBL Works National Faculty Emeritus. It's nice to meet you and see you for the 24 hours of PBL, and I'm excited to share with you a project that my students have spent some time working on. It's a plastics project. Specifically, it's looking at how we can reduce the amount of marine debris entering our oceans. What you see on the screen is a project that I wrote for PBL Works, which is available on their website. It is the Plastics Project, and it has quite a few learning goals in it, as you can see, many of which are related to science, but also to ELA literacy goals, reading and also writing as well. The basic idea behind this was I wanted to work with students to combine reading and research and inquiry with an understanding of how plastic affects both marine organisms and how we can do something about plastics once they are, out in the wild, but also really wanted to take a step back and look upstream. Where can we prevent plastics from entering our oceans? What can we do as individuals? What can we do as communities to try and limit the amount of plastics going into the oceans in the first place? So this was kind of the big first step. Instead of dealing with it after the fact, what can we do before the fact to make it less of a problem? Interestingly, we are at a point in history right now where we're looking at space debris. There are people around the world that are looking at space debris with the same sort of lens that people were looking at with marine debris 50 years ago. So that's going to be an interesting story to watch unfold over the next decade for sure. This project really had several different products that were going to be built, both as group products and also as individual products. One of the key things I really wanted students to focus on was summarizing their findings from both research and also data collection out in the field, which we'll talk about in just a moment. So I really wanted students to be able to write about what they'd learned, what they'd identified from personal observations and from inquiry. I also was looking for students to create as a final public product, a PSA or possibly a social media campaign. We opted for the PSA, public service announcement, because we have a working relationship with our city's recycling and waste division. The PSA would have an emphasis of education and awareness building, and also a call to action for residents in our community to do something, which was specifically to use our special waste collection center to deposit hard to recycle items, especially block styrofoam. And over the course of our field work and our data collection, and I'll show you those locations where we collected data in just a moment with a story map, an Esri story map, block styrofoam, polystyrene, was one of the things that we found quite a bit of in waterways. One of the first big milestones that I had envisioned for this project was having students research and do inquiry, traditional inquiry, in the classroom using internet resources, using reading, using audio, using video, and using experts as well to understand how plastic affects marine organisms. Some of those experts were National Geographic explorers that I've met through the course of my work with National Geographic. One of those explorers, Justina Mendola, is a Canadian scientist who's been studying microplastics and their ingestion by seabirds. Another explorer was Joe Cutler, who's a freshwater ecologist. And a third explorer, Dr. Caitlin Bowman, who is a marine plastics expert on the west coast of the United States, who also studies mercury and mercury attachment to plastics. So these were three wonderful people that we could turn to better understand how plastics are affecting marine organisms, where they're uptake in the food webs and such. So students were definitely going to become familiar with where plastic goes once it leaves their hands and possibly is ingested by other organisms. So this was a key milestone. Another key milestone that we really wanted to focus on for this project was, where in the food webs are these plastics entering? And what we ultimately learned through our inquiry, through our research, was that you see, plastics being uptaken or attaching to algae or to small aquatic plants, which are then ingested by small fish, which are ingested by larger fish. And we saw the whole idea of bioaccumulation take place in our research. At one point, we actually had gone to a couple of different locations to collect fish, to actually go fishing with Joe Cutler, our freshwater ecologist, and the gut was removed from these fish in order to be analyzed by Caitlin Bowman back in her lab. None of the fish digestive systems that we were able to extract show the evidence of plastic, but it was a really interesting process for students to go through that data collection process. Ultimately, we had quite a few different questions that we wanted to understand, which was, where are these plastics being taken up? Where are they being ingested? And by what kinds of organisms? And we learned quite a bit about that. A third milestone that we really wanted to tackle in the course of this project is, why are we using so much plastic? Why is this such a ubiquitous product? And in the course of our research, what we learned is that plastic is a product of off gases, from the petroleum industry. And when you have the petroleum industry producing oil and heating fuel and gasoline and diesel, and you've got these excess waste gases that are being able to turn into plastic, students started to realize that as long as fossil fuels are around, plastics are probably going to be around as well. We also realized too, in the course of the research, that we should take a balanced perspective. Plastic is not all bad. It's done some amazing things for saving lives, with plastic blood bags or plastic syringes or IV tubing. It's done wonders for keeping foods fresh and keeping things sanitary when packaged in plastic. But it's really the management or the mismanagement of plastic is the biggest problem that we have to deal with as a society. And this was something that students were able to understand more fully. We also learned too that just because there's a recycle symbol on a plastic item does not necessarily mean that it will be recycled. Students really started to learn about resin indicator codes and how certain plastics are more desirable than others. Some are more cost effective to actually actively recycle. So they started looking at plastics from both a business sense, from a use sense, and from a supply sense. Why is the supply seemingly endless? We wanted to understand where plastic leaves land and how it enters oceans, and that was really the bulk of the research or the field work that we conducted, was going out into the field and trying to understand, where would we look to see plastic leaking into the environment? And ultimately what we found was plastic that's mismanaged, plastic that doesn't go in a trash can, or if it's recyclable in a recycle bin, if it blows away or if it's dropped or if it washes away in storms, where do we see it entering? And one of the big vectors that we saw were storm sewers, which we have quite a few of throughout our relatively flat suburban city. And then, the idea of modeling, the idea of understanding, where do we think we'll see plastic accumulating? Where do we think we'll see plastic leaking? And then ultimately going out and ground truthing that, verifying with our own eyes. The other thing too that we wanted to understand and to be able to act upon was, how can we convince other people to responsibly recycle their plastics? And this was where the public service or the social media campaign came into play. We opted to build a public service announcement in order to educate people about how to recycle those hard to recycle plastics like block styrofoam. And then finally, the final big milestone for this project was, we wanted to educate our community by taking action and building a film, because that's something that we've done in our classroom for many years. So 6 big milestones for this project. And with that being said, the heart of it, the really cool part of it, being able to work with National Geographic explorers who had met, which meant we got to go out into the field and use maps and GIS tools. I'll share with you this quick video kind of overview of what we're looking at.
My name is Jim Bentley. I'm a National Geographic explorer with a Planetary Stewards Grant. I've been working with 5th grade students in Elk Grove, California, mapping how plastic moves from suburb to sea. Off behind me, you've got three large storm sewer outlets that form the headwaters of the Franklin Creek in Oak Grove, California. What we're finding is that plastic and debris is flowing into storm sewer outlets, which flow into creeks like this that head about 90 miles to the south and west that feed into the San Francisco Bay. Our goal is to understand where plastic is in our community, to tell a story about it using GIS, and then to present solutions to our city elected leaders on what we can do as a community to reduce the amount of plastic entering creeks that flow to the Pacific Ocean.
This project is also an attempt at starting a citizen science event where people with a QR code could actually collect data using protocols that students designed and built and actually filmed tutorials for as well. So as we see in the map, these dots on a map, the first place that we started collecting data was at our own school. And what you notice is these dots, the larger the dot, the more plastic we found, the smaller the dot, the less plastic we found. The darker the color, the more other trash. We sorted trash by plastic versus non-plastic. And what you can see is these dots are scattered what are it's seemingly random intervals, but every dot is actually a storm sewer inlet, one of those grates that you would see on a sidewalk or in a planter or on the curb of a street. These are the ingress points for water to be drained away from a location so that it doesn't flood. And this is a storm sewer network that really students were not even familiar with existing prior to this project. So they learned a little bit about city and urban planning as well. The next location that we went to was our neighboring park. This is our school off to the left. This is our community park, Kloss Park, as well as a green belt in the back of our school as well. With this, students started exploring their community with a whole new set of lenses, looking for storm sewers, looking for trash. This is the place in which they have lived their entire lives, and yet they've never looked at it from this perspective. And it was really fascinating to see how they viewed their community in such a different light. To the south of our school is a gated community, which has a lake as well. And this is called Laguna Lake. We went to Laguna Lake to do some fish collection. We were kind of curious to see if fish might be ingesting plastic in this lake. We had really successful days of collecting fish, extracting the gut, packaging them up in sanitary containers. And sadly, this was about the time the pandemic struck. So none of these fish guts were actually analyzed in lab due to complications with the lab access. So that was unfortunate. We did collect some fish in the Sacramento River whose guts were analyzed and showed no evidence of plastic ingestion. Another spot that we collected data at was Franklin Creek, the headwaters of Franklin Creek. They're actually formed by three huge storm sewers, and these massive blue dots that you see on the map indicate a massive amount of plastic waste that was found. Over I think over 14 or 1,500 individual pieces of plastic were collected here at the headwaters of this storm sewer. And that was kind of a really telling sign that we see these high concentrations, which eventually taper off the further we move away from these storm sewer outlets. Another place that we looked at was the terminus of Franklin Creek. It's about a 6.5 mile long creek. It's interesting to notice that these two blue dots in different sizes show different amounts of plastic. This larger dot, students realized was right at a storm sewer outlet, and it was a really big hot spot for plastic. Yet about 100 feet further down the creek, much fewer pieces of plastic. So we're seeing that these hot spots eventually will dilute and spread this waste. And students were able to see this visually by going out with a smartphone and a QR code reader and counting debris and logging it, and ultimately translating that into a map using an Esri map that you see here, which, by the way, is a free product for educators in the United States in K-12. Esri offers story maps and map access to their software. The Clarksburg boat launch that you see along here, we collected data for over 200 feet, linear feet, and again, huge hotspot concentrations of plastics This is a popular fishing place and a popular place to offload boats for a boat ramp. So what we're seeing as a result of this project is places where people congregate for long periods of time. We see high concentrations of plastic. Also, storm sewer outlets, we're seeing high concentrations of plastic. A similar pattern here at the Miller Ferry Bridge with students collecting data for about 150 linear or 100 linear feet. And again, the same kind of pattern here at Walnut Grove near a popular fishing spot as well. Large accumulations of plastic where people collect and congregate for quite a bit of time. Ileton Bridge, again, very similar pattern as well. Linear feet, maybe 100 feet or so. People, where people collect waste is going to be found. So ultimately, students were part of a data collection process and analyzing that data collection, looking for patterns. And some of the patterns we found was that plastic that is around storm sewer inlets is probably going to flow out at some point, and those storm sewer outlets did in fact show hotspots. So then it really came down to, okay, we understand how plastic is leaving land and going to creeks, which flow to oceans, and we're understanding the types of debris that are flowing out. What can we do about it? What steps can we take? And this is where the idea of creating a video, creating some sort of product with our city waste and recycling division comes into effect. And that's kind of the next big final product that we need to look at. While students were working with explorers to understand the nature of plastic and how it leaves land and moves into the sea, while students were understanding where plastic enters food webs and why we use so much plastic, they ultimately wanted to take some informed action in order to do something about reducing the amount of plastic entering our oceans. And that came in the form of creating a film with our city's waste and recycling division to play on the city's website and also to play at our city's special waste collection center, which would educate residents about how to recycle hard to recycle block styrofoam, which in our community cannot be put into a curbside recycling bin. So what I'll do is I'll play for you the Vimeo video that my students built for the City of Elk Grove's Recycling and Waste Division.
The City of Elk Grove reminds you that if you have styrofoam and don't know what to do with it, take it to the Special Waste Collection Center located at 9255 Disposal Lane in Elk Grove.
Residents of Elk Grove can bring styrofoam to the Special Waste Collection Center without paying a fee. The centers will be Sunday through Wednesday from 9 a.m. to 4 p.m.
When you drop off styrofoam, bring a valid California driver's license or utility bill with your address to verify where you live.
Any kind of block of styrofoam that you're accepted, such as the type used in packaging for appliances and electronics or the type used for coolers.
But styrofoam contaminated with food waste or other trash cannot be recycled and should be placed in your garbage.
Clean styrofoam clamshells, soup cups, or food trays can be recycled at the Special Waste Collection Center.
Some shipping stores may accept packing peanuts for use. If not, they can go in the trash.
Recycling styrofoam is important.
It diverts waste from landfills.
It helps reduce greenhouse gas emissions.
And styrofoam is a type of plastic. Properly recycling or disposing of it can help prevent plastics from entering Elk Grove and Sacramento County waterways, which flow to the ocean.
Recycling styrofoam.
It's easy to do and good for the planet.
When students think about problems like marine plastics entering the ocean, it seems like such a huge problem. It seems like something that's just, nobody can fix or solve or do anything about. But what students ultimately realized is that if they dig deeply and understand a problem, that they can actually play an individual role in doing something about it. This group of students, throughout the course of a grant that we received from the National Geographic Society, also received reusable utensils, reusable water bottles. These were badges of honor for kids to carry into the lunchroom or take out on the playground. These reusable water bottles were something that they grew attached to and attached stickers to. My own 3 daughters love their reusable water bottles and putting stickers on them to show where they've been and carrying them around, and as they collect dents and stories of where these things have gone to. it's something that they're kind of proud of, and it's something that I'm proud of too with my own water bottle. So it's really about understanding something, but also developing a mindset and an attitude that each of us can take a step and do something in order to make a difference. The video was a group project. This was something that students worked together on to collaborate with. The writing was done in groups. There were individual reflections, there were individual summaries of research, but ultimately, this final big public product, this film, was a group created event. Another thing too that we worked on building together was a story map, and this was kind of the story behind the story. This was another opportunity for students to process what they'd learned from their data collection. This was an opportunity for students to work in groups and to tell their own story, because if we've learned anything, it's that if you don't tell your story, nobody else will. So this was a narrative, if you will, of the project itself. This story map built by us and using Esri's story map tool was not necessarily one of the products that I envisioned being part of this project. But I think moving forward, I really want to build a narrative component to every project that we do in order for students to tell the story of their process as they engage in projects. So you can see for a story map like this, you can incorporate maps, you can incorporate text and hyperlinks as well. The map again that you see here is the map of our school with the adjacent park and also Greenbelt. We wanted to tell the story of this grant through this scrolling toolbar off to the side. One of the first key things that we had to figure out was, in a city of 170,000 people, where do we actually go and look for data? We have 40 square miles of Elk Grove. Where do we do this? And based on some initial research and inquiry, we found that plastic was entering oceans from waterways. So naturally, we started focusing on our waterways and, what are those waterways like? This is Franklin Creek. We spent quite a bit of time in Franklin Creek, both at the headwaters that we're flying over right now and also at the terminus at the end of this flyover. What students discovered through observation was that storm sewers in these creeks had these hotspots, these concentrations of plastic, which then led us back to, okay, well, if the plastic's entering the creek at these storm sewers, how are they getting in? And that's where we started to build our protocols for data collection. And that's something that students were able to create as well. So what you'll see is a series of protocols using a Survey 123. This is the Survey 123 app. It's an Esri product. And basically, it's just a survey that students can fill out on a smartphone by entering names and schools. You can actually have a photograph upload as well. Students were counting how much debris they found in a particular area, uploading that number. It was plastic and other trash. Those were the only two categories that we used. And then actually students can even add a photograph and then select a map point. So this would actually use your smartphone's GPS location, and you could put a point on a map. There's so many apps that use this kind of technology now. So this was a real world authentic tool that people use. The other thing too, if we wanted other people to help us, we needed to give them access to data collection forms like we were using, and also the survey like we were using. So we were able to use a QR code that you can see here. But we also wanted to make sure that students were collecting data, or individuals were collecting data accurately. We wanted to have some protocols. So this was an example of a tutorial on how to fill out Survey 123. We also had tutorials on how to collect data in parks near storm sewers. We had tutorials on how to collect data in storm drains, in paved areas, parks, and also along waterways too, because we figured we'd look along waterways, we'd look at these storm sewers. And here, I'll just play a little bit of this tutorial that students created.
Hi, we're students and we're on a mission to reduce plastic entering our oceans. If you're watching this video, you can help too. We're mapping where we find plastic to understand how it moves from land to sea. You can help collect data using the Survey 123 link provided.
In this video, we want to show you how to collect data along waterways. You'll need some materials: a tape measure or a piece of rope that's 20 feet long, a garbage bag, gloves or trash grabbers, and a data collection kit. You can download one using the short link provided. A smartphone with a camera and self-service.
First, you want to choose a waterway where you can search for plastic waste and other trash. Remember, be careful and be safe. Only search near waterways if you got adult supervision with you. For this project, we'd like you to search in 50-foot sections along waterways for plastic waste and other trash. That's about the length of 3 full-size cars parked in a straight line.
Use something to mark the beginning of your 50-foot section. A flag, a stick, a rock, or anything nearby. Use a long measuring tape to mark 50 feet or use your 20-foot rope. First, have one person hold the rope and another person walk out 20 feet. Then, measure another 20 feet. Finally, fold the rope in half to form a 10-foot section and measure 10 more feet. Mark the end of your 50-foot section.
When you've done that, collect trash and put it in 2 groups, plastic and other trash. Tally the trash as you find it.
Make sure you wear protective gloves as you gather trash and avoid any hazardous items. Make sure to throw away any trash you collect responsibly.
Now it's time to watch the next tutorial to learn how to enter the data you collected into the Survey 123.
See you later, explorers!
As you can see, students were very professional in terms of how they presented what they were looking for and how they were encouraging others to join them in their exploration as well. The ultimate findings that the project brought forward were some claims. And first claim was that plastic waste and trash accumulate along borders and boundaries. We noticed planters with raised curbs, brush lines, tree lines, landscaping were natural collection places for plastic waste, which means it's a natural place to look for it. We also saw that where there's a high volume of foot traffic, typically speaking, trash accumulates. A third claim that students were able to make, and this really kind of gets into NGSS, making claims and backing with evidence, was that trash and waste accumulate in places where people spend long periods of time. And then finally, a fourth claim was that plastic waste and trash hotspots occur at storm sewer outlets. And fifth claim, plastic waste and trash collects in storm sewer inlets that are filled with leaves. In all of the places we went to, most of the storm sewers are empty except for one that was chock full of leaves. So ultimately, what do we have? We've got a project where students are using research and inquiry both in the class, on the web, and out in the field. They're addressing a real world problem. How do we limit debris entering our oceans? And then they're taking individual steps, but also collective action to inform a public about what steps they can take as well. This is the PBL Plastics project that I'm very proud of to work with my students. You can find it at PBL Works website on their project library, and would love to chat with you more about this on Twitter. You can reach me at curiosity_films. Thank you for your time today.